Hello, 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 hello. Can you hear me? If you can hear me, put your name in the chat. Put your name in the chat if you can hear me. If you can hear me, put your name in the chat. Let's just give your friends a few minutes to join and let's enjoy. Let's get everyone. Put type your name in the chat if you can hear me. I'm just making sure you can all hear me. Yep. And we get to work. Preparing for the 2025 paper 2, which is on Tuesday. So yeah, we want to be ready. By the time Tuesday comes, we should be ready. We should be well prepared. I know you will be. So we're going to enjoy ourselves going through the papers, just revising some things you've already done. Hi, Sanya. Yes, definitely my favorite student. Number 1 in the chat. I see you. I hope you're good. Yes, if you can hear me, put your name in the chat, everybody. If you can hear me, I want you to put your name in the chat. Hi, Sanya. Yes, welcome. You're the number one person in the streaming. Good. Let's see who else just joined. You're now share the link with people from all your schools. Share the link around, Sanya. Put it in all your chat groups. Let everybody join who wants, and let's do some papers. Let's enjoy. So just share the link around, and let's enjoy it. Okay, it's gonna be fun. I want everyone. I'm going to be making sure everybody in our group has joined, and yeah, share with people from Kaswe. And if you know anyone else who's writing IG, just share it. Right? Yep. Time. Let's enjoy. I want us to enjoy. I want us to go through papers and just today and tomorrow. Are you guys going to school tomorrow? Tell me, are you going to school tomorrow, people? I want to know if we should go live again tomorrow or like tomorrow during the day. If you're going to school, tell me so that I know, and then I can put your name in the chat. Everyone, if you have joined, put your name in the chat. I see it's 2 other people. Put your name in the chat, guys. Put your name in the chat. Let me just be calling your people here, making sure everybody comes and joins us, and we have fun. We just do some papers. Are you going to school tomorrow, people? Tell me if you're going, yes or no. Put a yes or a no in the chat so I know if you're going to school tomorrow. I want to know that. Hopefully not. Do you have an exam tomorrow? Is there an exam tomorrow that you're writing? Or the first exam is math on Tuesday? What is it? Who is the other one in the chat? Futuristic. Who is futuristic? Oh, you're going to school tomorrow? Who is that? Futuristic. What's your name? What's your name, futuristic? Oh, Dante. Hi, Dante. Hope you're good. hope you're good. Okay, you're going to school tomorrow. Wow. What time are you coming back, everybody? What time are you coming back? Ooh, let me just start. I'm about to start. We're about to start for tonight. We just do what we can tonight. We are going to do more things tomorrow. We'll do more and more and more. Today we'll do some papers. We'll discuss. We'll see what it is. We can do one, really have a look and discuss it together. Make sure we are good. We are ready. Tomorrow we do more papers. We try to see how much we can go. I'll go live tomorrow at 7, exactly 7. I will be live. Then, yep, we're gonna enjoy. We should have fun. This whole exam season, I'll be live every day. I will be live every day, and we'll be doing papers and just enjoying ourselves and seeing how it goes. I want us to be live every day this whole exam season. So I hope you guys will be ready. Right. I'm going to start. Let's start now. I'll leave the video on YouTube in case your friends see it later, like tomorrow, anything, and they can still join us and see what we are doing tonight. So let's go through, guys. I have the May June papers. Have you done them? Have you done all three of them? Like 21, May June paper 22, and May June paper 23. Have you done all three of them? If not, then which one should I do first? Give me, then I'm going to like the one you choose is the one I'm going to do. Just choose and then we kill it. I'm ready. So I've put these May June papers for you guys, and I want us to do them and talk about them and go through them. And yeah, I want you to enjoy yourselves in this chat. Remember, every night we will be live together. So during the day, you send me your questions and things you want me to cover in the live video, and then in the evening, oh, hi Hillary, in the live video. Which one should I go? Which one should I start with? I'm going to start with paper 21. Let's start with paper 21. We'll do the others again tomorrow. We'll be enjoying ourselves. Everybody, put your name in the chat. Hi, Hillary. I see you. So I see Dante, Hillary, Sanya was the first. Everybody, put your name in the chat and let me see your names. Let me enjoy. So here, this is going to be exams 2025. 2025. Right. Now let's go for it. Let's go for it. Let's go for it. Now let's see. Let's discuss. What I want to teach you first is not just the solutions. No, I want us to discuss the paper together. Calm our nerves down, enjoy, make sure we're not going to be scared. We'll be seeing what they like to answer, like what they like to ask, like the questions they like to ask for each of these topics. Let's have fun. This is time to have fun. Let's have fun. So right now, what I'm going to do is, guys, remember that the IGCSE structure is going to be like this. So if you have a weakness right now, I want you to make sure you tell me tomorrow during the day, and I'm going to get time to highlight it. So what we are going to do first, before we answer our questions, maybe, is to kind of like put the chapters. Then we see which chapters they like to answer in the paper too. We're trying to spot. We'll try to spot, and we'll do the specimen paper as well. By the way, we're going to do the specimen paper as well together. So here it is. Remember that it's number. Then we are not going to be scared. Okay, we are not going to be scared. There is number. Then there is going to be algebra. Then there is going to be shape and space. Algebra. Then there's going to be shape and space. Then there's going to be the last one, probability, right? So the last one is probability and stats. So let's see what they like to ask in these paper twos. We're going to analyze all of them. The ones for October, for May, June, and the ones for February, March. Right. So now, okay, Sanya, I will not disappear. This whole exam season, like I said, guys, I will be live every day. So I want you to send me hard questions. I want you to send me all the hard questions, and I'm going to be there. and I'll be there every night. I promise. It's my promise to you guys. We'll be having fun. Send me all the things that you're struggling with. I'm going to be showing you the structure so you identify to say I have a weakness here and here and here, and we are going to focus on those weaknesses. I'm sorry, guys. I won't. This whole from now till November. When you finish with the multiple choice papers, I will be with you, going paper by paper by paper by paper, and we'll be just doing past papers, revising, putting all the things inside you. We'll be doing together long sessions, crash course. Yeah? Let's crash the course. Let's have fun. And what I want you to do is make sure you send this YouTube link to all your schools, guys. Send to people from all your schools, the groups, all these school groups and class groups and whatever. Let's have fun, all right? I want you to be like 500 people. Dante, like the whole of, is it Wystick? And then John Mackenzie, and then Casway, and then Rainbow, and then whatever school, and we have fun. So here, so remember that number is, okay, just those basic topics that you really don't know where they're from. Those questions where you really don't know where they're from are from this topic. Like things like proportion, time, calculation. We'll see which topic comes out the most in this paper together. So we have proportion, we have time, then we have interest, then we have probability and statistics, then, what am I saying? We have interest, then we have sets, we have sets, then we have percentages, and then we have bounds. Percentages, that's when you have percentage increase, percentage decrease, reverse percentage. We have bounds. Then we have let me think. These kind of things. If you have like a weakness with this, I want you to tell me, and then we're going to make sure that we cover this. Okay? To make sure you guys are more than ready. If you have a weakness, you should tell me where your weakness is in these things, right? Okay. And then of course that's where you're asked about the types of numbers, and they'll see if you can put in sequences, where they talk about prime numbers and all these other things. We'll see. Then algebra, we will start with what? With linear algebra, where you're going to talk about midpoint. So I'm going to list the things so that you guys can see midpoint, and then gradient, and then equation of a line, equation of a line. And when they talk about things being parallel, relationship of gradients, parallel things, and they talk about things being perpendicular. This is all stuff that is coming, that is in algebra. And we have other things as well, man. Like we have those, completing the square. We're going to make sure we are good at all this. So anything I'm going to see in these papers, I will hammer it into you guys. Make sure whatever way it comes, you are good. Completing the square, factorization. I want you to remember the structure as you solve, because it is going to keep you intact. You won't panic as you do this, right? Completing the square. And we have, what else, man? These are the things, let me think. Differentiation, and we have graphs. I'm going to make sure you guys are good at graphs. Whatever graph question we see in this paper, we'll focus on it, right? Then what else? So shape and space now. This is where you have geometry, circle theorems, right? So let's put it. Let's say you're going to have circle theorems. Let me put it back. Here you're going to have circle theorems. Then what else do you have? You're going to have, let me think. Circle theorems, and then you have relationship of parallel lines, right? To say what is things that are alternates. Alternate angles. Everything is about angles in here. Alternate angles, then you're going to have allied angles, then you're going to have corresponding angles. You have to know all this. Then you have to know trig. Okay, in trig, you have to know Pythagoras, you have to know SOHCAHTOA. I'll teach you what we call 3D Pythagoras. I'll just show you a question in case it comes. And then you have SOHCAHTOA. Then you're going to have sine rule and cosine rule, sine rule and cosine, and then you have all these other things. It goes down to trig graphs, and then trig equations. So let's put all that. So we have trig graphs, and then we can have trig equations. Trig equations, you solve them using what we call the the cast diagram. So you guys have to be good at that. And then you're going to have here I left things like solving equations, yeah, by even the Pythagoras, the what is it, the formula, quadratic formula. So we'll talk about it. But you'll be given, so it's given in the exam, so it's not something we ever have to worry about. Trig equations, all these things. What else did I leave now? Mensuration. Wow, there's going to be a lot in this one, and then vectors and transformations. I want to answer a question on vectors. I definitely want to answer a question on vectors, just to make sure you guys are ready for this. So yeah, vectors and transformation. Now, probability and statistics, what do we have? So for probability and statistics, well, we have probability. In probability, there is basic probability, where they'll say, find the probability that this happens, this and this happens, this and this happens. And then sometimes you may use a tree diagram. So let's put, for probability, first you have questions where you use the keywords and then the other keyword or. You need to know how to. Then for probability, you need to know how to do tree diagrams. Okay? Then you need to know what we call conditional probability. Conditional probability, where you pick without replacing, where they pick and then they don't replace. So we'll see how that works. And then we do stats. Now in stats, you have the stem and leaf, that is representing. You have the box and whisker. You need to be good at that. You have the cumulative frequency curve for graphs. You give the cumulative frequency curve. Then you have the histogram, right? Then now after that, you have calculations for statistics, which will be now mean, median, mode. You need to know, okay, what do you do when you have, again, mean of group data? Let's say mean of grouped data now. You want to know, how do you get the mean of grouped data? And then you want to know, how do you get the upper quartile? You know, upper quartile, how do you get the lower quartile? How do you get the interquartile range? And then how do you get range itself? Range is just highest value minus lowest value. Okay, so, wow, okay, this is nice. This is fun. Let's see the paper. Let's see the paper. Let's see where the questions are coming from here. It's time to shine, guys. It's time to shine. We're getting started now. Let's see where the questions are coming from. Right? Let's see where the questions are coming from. So here we go. Okay, I'm going to have these formulas, and when I look at these formulas, right? When I look at these formulas, I'm going to see that most of them are from mensuration. So mensuration is going to need formulas, and all these formulas are from mensuration. They help you to find volumes and areas, but remember, when you are going to get the question, usually the shape will be cut up. The shape is going to be cut up into parts. Okay, guys, keep commenting, liking the video, everything, doing reactions. I like to see them. So here, remember that this is mensuration, but when you do it, it won't be just a cylinder or a prism like this. You're going to have different shapes joined together. So make sure that for that you can be able to recognize. And then you're going to have the quadratic formula. So you have factors from, you have formulas from mensuration. Then you have the quadratic formula, okay? Then you are going to have this one now. This is going to be for what? This is going to be for non-right-angled triangles. Non-right-angled triangles. Here you are going to, if you're doing a question to do with the non-right-angled triangles, then the things you're going to use are going to be from this side. The thing you're going to use are going to be from this part here now. For non-right-angled triangles now, the things are going to be from this part, right? Yeah. So, okay. So I have mensuration. I have the quadratic formula. And then I have things from non-right-angled triangles. So they actually explain to you what the quadratic formula is. To say when you are putting this quadratic formula, make sure A is going to be the number before x squared. B is the number before x. And C is the number which stands alone. But remember, when you put it, remember to make sure you do not make a mistake on the sign. You can't. Okay, if C is negative, remember when you put it, make it negative. When you put it here, when you put it C, make sure it's going to be negative. Now let's see the questions. let's see the types of questions that come for this paper. Let's see it. Here, calculators must not be used. Who cares? We don't need it. We don't need you, Mr. Calculator. I don't need you. I'm fine. This first question, simplify. Well, this one doesn't need a calculator. Nothing hard here. Second question, okay, so for this one, I do not need a calculator. I'm simplifying. When I simplify, I know that I only work with things that have the same letter. So I have this, so for this one, okay, we'll come back to solve it. I don't want us to solve, although we attempted to. Now, what about this one? Well, here is the stuff I was telling you, that this stuff comes in this section here of geometry. These alternate, allied, and corresponding. Okay, these are angle properties of parallel lines. When you get parallel lines, you are going to use these ideas to say what are alternate angles, to say what are allied angles, what are corresponding angles. We'll talk about them, but you gotta know. So, okay, this second question was from that. And why is it that he doesn't need me to calculate? Because there's nothing big here. There's no big calculation here, guys. There isn't. There's no big calculation here. We don't need to do a big calculation. Well, okay, are you telling me? Yes. These sides, we're going to be using something to do with these parallel lines. The parallel lines are going to be these ones with arrows. They are parallel. So we are going to follow something about the angle properties. Okay? And I'm going to be able to find W, X, and Y. Now, the secret is you are going to first use angles that you know to see what else do I know using that. Oh, we'll come back. So for this one, did I need a calculator? No. Because most of them, either you're going to have to find X and Y or whatever as being equal to 76, or you'll find it as being equal to 76 minus 180. You know, it's nothing complicated. It's something you can do with your hand. You must be able to count, to subtract with your hand in parts. So for this one, I do not need a calculator. I'm not punching sine of something or cos of something or tan of something. It's nothing big. I don't need a calculator for this. So I can't panic. Okay, no wonder why they said it's a no calculator paper. I don't need a calculator for this one. I need to know the angle properties. If I know the angle properties, then I'm fine. You see? Then let's go for number 3. Simple interest. Okay, we'll solve, don't worry. We'll solve the question, but here we invested at simple interest. The moment I say simple interest, we know its interest is equal to principal times rate times time. So it's a small calculation where it's going to be 1,500 times 3 times 6, which is the time, all divided by 100. Okay, it's principal times rate times time, all over 100 if you want. That's another way to put it, like this. This is whenever you see the word simple interest. So do I need a calculator for this? Not really, okay? I don't really need a calculator for this one. 1,500 times 3 times 6, I'm going to have to do it with a pencil or something. I don't need a calculator for that. No problem. Here now they say work out. So in here, now they're saying work out this, blah, 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 blah. So for this one, what do I need to know? I need to remember the order of operation. What do I start with? A subtraction or a multiplication sign? And you'll be needing to know bead mass. Then we'll do it. But there's no need for calculator. I don't see where we need a calculator so far. This is just going to be multiplying and then subtracting. There's nothing big here. There's no big math that I'm going to say I need a calculator here. So far, I don't see where I need a calculator. Let's see number 5. The interior angle of a regular polygon is this. Find the number of sides. Here I'm going to teach you what to do on this one. But there's no need for a calculator here as well. You don't need a calculator. So here, I don't see a calculator question here. This is properties. You gotta know some properties of polygons to say how do you find the interior angles, because here you've been told that it is the interior angle. Then they want the number of sides. There is a formula, right, for the total angles that are inside A. So here they're saying, guys, what we know is that, somebody please like the video. Drop a W, please type comments and like the video, whatever. Guys, for this one, the secret is this. You have to remember the formula that says that the total degrees, okay, the total interior angle, the total angles, okay, or sum of angles. You can say sum of interior angles. The sum of interior angles, this is going to be equal to n minus 1 times 180. Is it n minus 1 or n minus 2 times 180? It is n minus 2, sorry, times 180. The sum of interior angles is n minus 2 times 180. This is where it's coming from. There is no calculator I need. It's n minus 2 times 180. So here I would say, what is the sum of interior angles? I've been told that one angle, an interior angle, is 150 degrees. One angle is 150 degrees. So let's say that this polygon has n sides because they want the number of sides. So it has n sides, right? So I can say 150 degrees is the angle of 1. If I multiply that 150 by n, what will I get? Let's say that a triangle, come on, you guys are good at this, right? Because here they said it's a regular polygon. Guys, it's when they use the word regular polygon, it means that all the sides are equal. That's what it means. All your sides are going to be equal. That's why it's a regular polygon. So all the sides are n. So let's say that I have a triangle, right? And this triangle has 3 sides, and each side is n, 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 right? Each side is an n. Now, let's say that I'm using this same formula, right? Which says that the sum of interior angles of any polygon. A triangle is a polygon. It is. It has 3 sides. So now you'll be saying the sum of the angles should be n minus 2 times 180. Is that true? Yes. That's a formula. Now I'll be saying, okay, so what about for my triangle here? How many sides do I have? 3. And what are they? They are all n's. So we can say 3 times n. This should give me n minus 2 times 180. Okay? 3 sides times n. Is it not? Should give me n minus 2. Then I'll be able to find the n, right? This is going to be whatever. Or, no, here we can also say, let's say that we are told that here, sorry. Let me edit it a bit. Let's say that this is n, this is n, this is n, right? Let's give n a value now. Let's give n a value because I don't want to call it n because n is for number of sides. So let's call it x, sorry. X. For us to use this, we're going to say x is the angle for 1. Is one angle, right? X is one angle. So what's up? X is one angle, right, guys? So here what you're going to say, I just want to show you this. It's a 2-mark question, so I don't want us to waste time. Okay, remember, we do not dwell on 2-mark questions like that. Like, you know what I mean? You don't dwell on 2-mark questions like that, guys. But here's the thing. You know that each angle is x. Let's use our common sense, right? When I add these 3 x's, it should give me the same answer as saying n minus 2 times 180. Remember, n is the number of angles, right? The number of sides is the number of angles. So if I add, let's say these angles are x, whatever angle, we don't care. When I add these 3 angles, it should give me the same answer as saying n minus 2 times 180, right? So let's see, what is the way that I would combine these 3 x's? There are 3 of them. So I would say 3 by x. And what is 3? 3 is n. So it's like I'm saying n times x is equal to n minus 2 times 180. You see, you multiply one angle times the number of angles there are. So here would say, here 3 times x will give me 3 minus 2 times 180 degrees. Because I'm dealing with a triangle. That is if I'm dealing with this triangle. So I would say now 3x will be 1 times 180 degrees, right? I'm trying to prove to you that you don't need a calculator for this one. You'd now have x being equal to 180 degrees over 3, and you'd have x being equal to 60 degrees. So it's like you'll be finding out that, okay, each side is 60 degrees. That's kind of what it is. This is what we're going to do here. Look at what we have been given. They think we're not smart. We're smart. I know that the formula I have for interior angles is only for the sum, right? It's only for the sum. And there are 2 ways to get sum. Either I can add everything together, or I can say, since there are 4 x's, I could just say 4 times x instead of saying x times x times x times x times x. So here now I would be saying, for my interior angles, I've been told that one angle is 150. But remember, I want the sum. I want the sum. So I could either say 150 plus 150 plus 1 for the number of, or I could say, if this shape has n sides, then I would say 150 times n should give me the same answer as here, n minus 2 by 180. Then I would find what n is, because n is now the number of sides. They want n, the number of sides. So now we would find n and we'll be fine. So let's do it. That's the game. That's the game we do here. But there's no need for a calculator. We can even solve it now. To say 150 degrees is for one angle, an interior angle, times n, the number of angles, should give me the same answer as the sum, which is n minus 2 times 180 degrees. Right? Then now I'm going to solve for n, and I'll be done. If you want, you can write it in full the way to say sum, but write small things so that you can write on 2 columns, right? So you can say sum of interior angles. This is going to be equal to n minus 2 by 180 degrees. Now you'd say, okay, my sum is, I've been told that 1 is 150. So I'd say 150 degrees times n. This is equal to n minus 2 by 180 degrees. Then I find n. You know what we can do? We'll make this 150n. This is equal to 180 times n will be 180n, minus 2 times 180 is minus 360. Then which n is bigger, 150 or 180? Obviously 180. So what I'm going to do is take both ends to the side where the bigger one is. And the bigger one is 180. So I'm going to take both to 180, and I'll take 360 to the other side. So I'll have 360 is now positive. Here we still remain with 180n. 150 will now come to subtract minus 150n. So you'd end up having 360 degrees will be equal to 30n. You see, where do I need a calculator here? Rihanna, where? Dante, where do I need a calculator? I don't, right? So I don't care if this is a non-calculator paper. I don't need one. So it's 360 degrees divided by 30 is equal to n. Then whatever you get what? 0 and 0 cancel, 3 into 36. What is it? 12? This is going to be n. So you can say that it has 12 sides. And you're done. You get your answer. So is it about the calculator? No. What is it about? The theory. It's not about the calculator. The calculator doesn't change anything here. I don't need it. That's why it's a non-calculator paper. You don't need the calculator. It has nothing to do with the calculator, guys. It has everything to do with theory. Look at this one. On the grid, draw this line. I don't need a calculator to do that, right? This is a graph, so we'll talk about it. A line, really, simultaneous equations. So this question is linear algebra. It's asking about lines and all that. I don't need a calculator for that. Then recurring decimal to fraction. I don't need a calculator for that either. I do not. No, I don't. Changing a recurring decimal to a fraction. I don't need a calculator. Give me a sec, guys. Give me a second. Give me a second, right? calculator. Let's see down. Let's see the next one. This is vectors. Yes, I said I want to teach you vectors. You don't need a calculator for this, guys. No. Vectors, no. You'll be just adding. These are numbers. You just need to know how to do it. Then, okay, find the magnitude. Okay, this vector has a magnitude of, you need to know just how to find the magnitude of vectors. But it's another simple thing. You do not need a calculator for it. No. So far, I have not seen any question that has a need for a calculator. So if I'm not doing this well, it's not because of the calculator. Definitely not. Right? It is not because of the calculator. Wait, wow, what has happened? Give me a sec. Sorry. Just give me a second to make my screen visible again. All right. Now, I think you should be able to see my screen. Should be back by now. Let me see. Is it back? Guys? Yeah, it is. Okay. Now we go for it. So I said for this one, okay, vectors, we don't need to have a calculator, okay? This is just, do I know vectors? If I know vectors, I'm fine. And here is recurring decimal to a fraction. We're going to solve it, okay? We're going to solve it. But I wanted to prove to you that it's not about the calculator. So for this one, it is definitely not about the calculator. It is just, do I know all these things, these small things? Do I know how to do them, right? Look at this. This is statistics, and they've given me a very small table with frequency, and they want the value of n, which is this one, this last value in here, right? Okay, so we have the table which shows information, and they told you the mean. They told you the mean, then they want to. So we're just going to put the formula for mean, right? And then we're going to try and calculate it. Then we are going to make n the subject. Once we make n the subject, we are done. So is there need? Do I have need? No, I do not have need for a calculator here. The thing is, do I know how to get mean? That's the point, not the calculator. If I know the formula for mean, I'm fine, which is just the sum over the number of things. Like you add and then divide by how many things you have. Look at this one. Number 10, circle theorems, right? Circle theorems, you don't need a calculator. Nobody has used a calculator for circle theorems, right? No one has done that. So I won't believe that. Circle theorems is about circle theorems. It's not about the calculator. So we don't need that for all these angles. And these are all 1 mark things, you know. Look at this graph. What do they want from it? Drawing a tangent, but okay, we draw a tangent, fine. Find the equation of the tangent, fine. This is again fine, finding equation of a line. So there's no need for a calculator there. I don't see where you need it. Cumulative frequency curve, what do they want? Estimate interquartile range. I don't need a calculator. Use the cumulative frequency to find K, which is 70% have less than K. We'll go there, we'll go to 70% and we'll see what value it gives us for time, and then we'll be able to find whatever they need. It's using the graph, it's not the calculator. There's nothing that we punch here. Okay, so here that is when, let's see, but these are just small values, 10, 6, 4, and then they're asking me for total surface area. This one I'll be, if I don't know, I just go to the top of the paper. I showed you that the formulas they're going to give you are for mensuration. They are for this type of problem. They are for this type of question. So, but there's no calculator used there. There's no calculator used, guys. There isn't. Here's functions. We have functions here. They want us to find the inverse. Then they want us to find composition of functions, you know, where there is fg of x here. One function inside another. And here they want us the inverse. Then here, well, find this. We're going to create this. We'll remove f of x, put what it means. Remove g of x, put what it means. And then we're just going to solve that. No calculator involved whatsoever. Expand and simplify. No calculator. Rationalize the denominator. No calculator. Expand and simplify again. No calculator. Find the probability. How do you use with replacement? This is basic probability. If you pick and replace, that's basic. If you pick and don't replace, that's conditional probability. So here, this is basic probability. We are picking and replacing these marbles. So nothing is going to change. It's just about, do you know how to use the word and the word or? Because here they say, find the probability that both marbles are green. So in other words, it's green and green. So, and when you use the word and, it means multiplying, right? And then when you use the word or, you add. So that's all what it is. I don't understand. Look at this other one. Without replacement. That's now conditional probability. But they've given you a tree diagram for you to just fill up. How simple is this? Like, I don't understand. Where is it hard? Where? Find the probability that one of these counters is yellow. Okay, we'll use a tree diagram. We'll fill it up and we'll see whatever it is. Then write down an expansion. So you have to, do you know the tree diagram? That's the question. Are you good at the tree diagram? Do you know that the two branches should add up to 1? And do you know that if it's conditional probability, when you move from one branch to the next, the total reduces, and then the thing which you have chosen reduces. So that's all it is, nothing else. Look at number 18. First, it was an analysis of the paper, right? Write down an expression in terms of creating equations. That's all it is. Then show that it simplifies. Okay, they want us to create another equation. So it's just creating equations. Then is it the last question, number 19? I don't know. Here they want it's do you know the indices? Do you know stuff about indices? Like, what do you do when you have a negative power? Simple fixture. So we'll talk about it. Here, Pythagoras. Just look at this, guys. Just look at, no, this is Sokotoa. A nice right angle triangle. You have been given one angle, one side. And they give you 4 marks. Wow. Vectors again. Oh, vectors are back. We saw vectors twice now. Okay, so you got to be good at them. They're coming. Then here, find the turning points. This is completing the square. Find the value of n. What? This is differentiation. Okay, we have the derivative here. dy dx is equal to this. Find the value of n and the value of q. We're going to see how to do that. That's not even a problem. This is a little bit of differentiation, and when I have the derivative, to find the turning point is easy. There are 2 ways to find this turning point. One is by completing the square. The other one is by differentiating. So if I've been given it as a derivative already, it's very simple. I'll show you the difference between those 2 questions, by the way, in case you want to see, when I'm solving this number 22 just now. Here we have fractions that need to be simplified. Man, oh man, you factorize the top, you factorize the bottom, you simplify. And we're done. me test. 1, 2. Can you guys hear me? I'm back. I'm sure my video is back. Okay. All right. So yeah, you'd have my dy dx is now this. Now the turning point is always going to be the point where, like, I make dy dx equal to 0, right? The turning point is always where I make. So when I see them say turning point, I just write my dy dx, and I'm going to get turning point. Whenever they say turning point, you're like, nonsense. If you have y, first find dy dx, then make it equal to 0. Okay? Right? Good. So here we already have the dy dx. So you're just going to say let dy dx be equal to 0. So now you'd have your 3x squared minus 12x plus 9 equal to 0. And we just solve this thing, and when we solve it, we get the values of x. That means now we have found the coordinates of the turning point. And this is how nice and easy this is going to be. Is this hard? I don't think so. I don't think it is hard. So here we will have that, and you can say this is now a quadratic equation, and you must be able to solve it. So here, since there's 3 can go into all of them, so I will divide them by 3. So I'll now have x squared minus 4x plus 3 is equal to 0. Then I'm going to solve this one. This is the quadratic equation to be solved. And once I solve it, I'm going to say, let's put 3, the factors of 3 are 1 and 3, who will then combine to give us negative 4. It is when both are negative. Okay? They'll multiply to give us a positive 3. Yes, when both are negative. And they'll add to give us a negative 4. So it's going to be, am I done? Yes. So it's just going to be x minus 1, x minus 3 equal to 0. And you get x minus 1 equal to 0, or x minus 3 is equal to 0. So x minus 3 is equal to 0, which will give you x equal to 1 and x equal to 3. And you'll be done. So do I have it? Yes. But remember, they want coordinates. That's why they actually have x and y. X and y. So now you want your y. You now want the y coordinate. To get that y coordinate, remember this working which I have done here was rough working. They don't want to see it. You have the two values for x. Now we will bring back this y, right? Remember that y is equal to x to the n, then what? Plus qx squared plus 9x. So plus qx squared plus 9x. Now let's put what n is and what q is, and we should be able to have it. So y will be equal to now x to the 3 plus q is negative 6x squared plus 9x. Isn't it? Then now we can have this. So we are going to put the two values for x, and we are going to get the value for y if we put the two values for x. Isn't it? That's how it is. This is nice and easy. So we're just going to put, okay, we'll say let x be equal to 1. We'll have y is equal to 1 minus 6 by 1 squared plus 9 by 1, which means y will be equal to 1 minus 6 plus 9. Okay, 1 minus 6 plus 9. Make sure you're careful with this one. 1 minus 6 will give you negative 5. Plus 9, you have 9 minus 5, you get 4. So y will be equal to 4. Nice and easy, right? Then you can say again, let x be equal to 3. You now have y is equal to 3 minus 6 by 3 squared plus 9 by 3. Stuff like that. And you're going to get the other one, right? Good. Just give me a sec. Give me a sec. Give me a second.